All right, so our warm-up was a little summary of what we did yesterday. So part A wanted you to add, if possible. Can we add these together? No, why not? They're not the same dimensions. What is the dimension for the first one?
2 by 1.
This is a 2 by 1, and what's this guy? A 1 by 2, so like it's flip-flops, right? But it's not possible because it is not the same dimensions. So we cannot add those together. Okay, how about part B? Can you multiply by the scalar of 3? Yes. To do that, we just distribute it all the way through. Who wants to give this to me? Julian, go for it. Thank you. Good. Good. So that was scalar multiplication. Today, we're doing matrix multiplication, which is different, and it has its own set of rules. Okay? Adding and subtracting, they had to be the exact same dimensions, same size, right? Scalar multiplication, no rule needed. Just distribute that buddy all the way through. Okay? Matrix multiplication, okay? The product of two matrices A and B is defined provided the number of columns in A is equal to the number of rows in B. Okay? So if A is an MN matrix and B is an NP matrix, see how these are the same thing? Okay? Then our product matrix is going to have dimensions M times P. I feel like the picture shows that very nicely. So if my two pieces in the middle are equal, my two pieces on the outside are the dimensions of my product. Okay? So in part A of my warm-up, I could not add those together, but guess what? We could have multiplied them together. Okay? Because the rows of the first, I lied. The columns of the first match the rows of the second. Okay? And so this, if I did multiply these together, I would have had the dimensions of a 2 by 2 matrix when I was done multiplying. That's how that would have worked.
And that's because you're multiplying the rows of the first one by the
Columns of the second.
columns of the second.
Yep. Yep. So if these middle pieces are equal, then my outside gives me my dimensions. So this is a very good visual. If you are a visual person, I like that a lot. Okay, so let's just figure out, can I or can't I multiply before we actually start doing it? Okay, so our first example, what are the dimensions of matrix A right here? Good, we have 2 rows and we have 3 columns. Okay, can I multiply that with matrix B? What are the dimensions of matrix B? Good, 3 rows, 4 columns. So can we multiply? We look right here. Yes, we can. Those match. So yes, we could multiply these. And if we did, what would the dimensions of the product matrix be? A 2 by 4. Good. Again, these come from the rows of the first and the columns of the second. So because our middles match, we can multiply, and our answer matrix, our product matrix, will have the rows of the first and the columns of the second. Okay. How about example B? What are the dimensions of matrix A? Good. 2 rows, 3 columns. What are the dimensions of matrix B? 2 by 3 again. Can we multiply these? No, we cannot. This would be undefined. Because 3 and 2 were not the same, we could not multiply these together. What could I do with these, though? I could add them. What else could I do? I could subtract them, because they're the exact same size, but we could not matrix multiply them. So you ready to multiply? Yeah? Let's do it. Here we go. Multiplying matrices. To find the element in the ith row in the jth column of the product matrix AB, multiply each element in the ith row of A by the corresponding element in the jth column B, and then add the products. Okay? Again, I like the picture. I think the picture is more clear to me than I and J and all that stuff. Okay? So the reason why they have to match, you take the row, the first row, you multiply it with each corresponding piece in the next column, and then you add each pieces together. So you multiply, add, multiply, add, multiply, add, multiply. As you work across, you multiply as you work down. That's why they have to have the same amount. Okay? If I'm trying to find the first row, first column, I'm going to use the first row of A and the first column of B. Multiply, add, multiply. Alright? If I'm trying to find my first row but second column entry, I use my first row of A and my second column of B. Multiply, add, multiply. Yeah? If we're trying to find my second row and first column, I use the second row of column A and the first row of column B. Multiply, add, multiply. So you multiply each entry to each other as you work your way down, and then you add them all up. All right? So let's do one. Okay? I've given you matrix A and matrix B. We're going to multiply A times B together. Okay? Then we're going to multiply B times A and see if matrix multiplication is commutative or not. Okay? So like in the real world, 5 times 2 is 2 times 5, right? We're going to test, do matrices follow that same rule? Okay? So here we go. We have A times B. Okay? These are square matrices. They're both 2 by 2s, right? So we can multiply them. And when I do, my product matrix is going to be another 2 by 2, right? So these match. So our matrix on the outside will have a 2 by 2. All right. So let's start putting things together. Put together your first row with your first column. So then I'm going to multiply 3 times negative 1. And then I'm going to add to that 2 times 6. Do you want to work down or across? How do y'all want to work? Across? Okay. So we're going to stick with 3 and 2, right? But now we're going across over here to column 4, 5. So now it's 3 times 4 plus 2 times 5. Okay? My row number stayed the same because I stayed in the same row. The 3, 2 is there for both of them. All right. Okay, so let's move down to our second row. So I have negative 7 and 8 for my second row, and we're going to use negative 1, 6 for my first column. So negative 7 times negative 1 plus 8 times 6. Something else to notice. See how I use the same column numbers, negative 1, 6, and they are in a column of each other in that first column? Okay, you're going to see math patterns like that show up. All right, last one. So we're going to do second row and second column. So negative 7 times 4 plus 8 times 5. All right, let's do some math, friends. 3 times negative 1 is negative 3. 2 times 6 is 12. What is negative 3 plus 12? 9. Okay. My next piece is going to become 12 plus 10, which is 22. Negative 7 times negative 1 is positive 7. And then plus 8 times 6, which is 48. That gives me 55. And then our last entry is going to be negative 28 plus 40, which gives me 12. So there's our AB matrix. Okay. So we're going to switch them, do it again, and see if we get the same thing or not. Okay. You ready? All right. So for BA, we're going to have negative 1, 6, 4, 5 first. And then 3, 2, negative 7, and 8. Would you like to try? Yes. Let's have you try this one. All right, so look up here when you're ready. What's up? Oh, in a minute. So our BA matrix is going to be negative 31, 30, negative 17, and 52. So, do they match? They are not the same. They are not the same. So matrix multiplication is not commutative. What does that mean? It means order matters. Okay? Order is going to matter with multiplying matrices. Okay? What's the only possible way that it would be the same backwards and forwards? If it was the exact same matrix. Yep. What if one of them was a zero matrix? Yeah, that would, because if you multiply by 0, it's going to be 0 regardless, right? So if a zero matrix is in there, or if it's the exact same thing multiplied to each other, then order would not matter. Okay? And that would mean it would have to be a square matrix, right? All right. So, it doesn't follow the commutative property. Doesn't follow the distribution property. Okay, that's the next thing we're going to test. So on the back, we have 3 new matrices. We have a matrix A, matrix B, and matrix C. I want to know if I do A times B plus C, is that the same as A times B plus A times C? Okay, so does the distributive property work with matrices? What is the dimensions of matrix A? 3 by 2. And what are the dimensions of B and C? They are both 2 by 2s. So can I add B and C together?
Yeah.
Yes. And then could I multiply that with matrix A?
Yeah.
Yes. Our dimensions are good to go. All right. So let's add. Here we go. So matrix A, which is going to be 5, 3, and negative 4, 7, 1, and 2. I'm going to go ahead and add these together to help us with some room. So to add B and C together, we do our entries added to the matching side. So 0 plus 2 is 2, right? 1 plus negative 3 is negative 2. 3 plus negative 1 is 2. And then negative 6 plus 5 is negative 1. All right. So I just went ahead and added those together. Now let's multiply. Okay. So we have a 3 by 2 matrix this time. So when we multiply a 3 by 2 with a 2 by 2, what size is our product matrix going to be? A 3 by 2. Good. So because these match, these guys give us our product. All right. You ready? All right, so we have first row, first column. So 5 times 2 plus 7 times 2. I'm just going to work my way down. I'm going to do my second row with the same column. So 3 times 2 and 1 times 2. And then my third row with that same column is negative 4 times 2 plus 2 times 2. So again, knowing that that column is the same, see how my parentheses is the same for all of them? Our math makes sense. I use the same column each time. But my row values changed. Bless you. All right, so let's move over to our second column. Okay, so we have 5 times negative 2 plus 7 times negative 1. We're going to continue using that same column, right? So I know all my parentheses are going to be the same. Row 2 is 3 and 1. Row 3 is negative 4 and 2. Let me go over here. All right, beautifuls, here we go. What is 10 plus 14? 24. Let's go down. What is 6 plus 2? 8. And then negative 8 plus 4. Negative 4. Do we know where those numbers are coming from? We get what I'm doing? Yeah, I'm multiplying. Cool. All right, next column. Negative 10 plus negative 7. Good. Negative 6 plus negative 1. And positive 8 plus negative 2. Positive 6. Good. All right, so let's see. If I distribute my A to each matrix first and then add it, do we get the same thing? Okay. That's a lot of multiplying, right? And not a whole lot of space maybe to show that. You ready? Are we ready? Do you have these? I want you to look under the math button. And what is written on your calculator? Matrix. We have a matrix button. Okay? Push second and matrix. You are able to put matrices in the calculator and do operations with them. Okay? I had to show you by hand so you knew what was happening, but there is a way for our calculators to help us, okay? So we have to tell it what is matrix ABC, okay? So we're going, if you already have, so when you go over to edit, if you already have something there, it's okay. We're just going to type over what you have, all right? So go over to edit. You're going to click on matrix A. If nothing was there, it looks like this. If something is there, that's fine. We're just going to switch it up. Matrix A, we already said was a 3 by 2. So push 3, enter, 2, enter. And it'll replace what was already there, if something is there. Okay. Now we're going to put in our values. It goes across the rows. So 5, 7, then 3, 1, pushing enter each time to move forward. And then negative 4 and 2. Okay. This is a great feature as long as you type in the right numbers. So don't go too fast. What's up? Get where? Second matrix and then go over to edit. Okay. So we're going to do the same process for matrix B and the same process for matrix C. Okay, so again, second matrix, I'm going to go over to edit, and now I'm going to edit my matrix B. Matrix B is a 2 by 2. 2 by 2 with the values 0, 1, 3, and negative 6. Last time to put in matrix C, second matrix, go over to edit, and now I'm going to plug in what matrix C is. So go down to C, push enter. Matrix C is also a 2 by 2, and the values are 2, negative 3, negative 1, and 5. Once you have all of them in there, go back to your home screen by pushing second quit. Yep, it's red up there because it was the last button I pushed. Okay, so we want a blank screen because now I can bring my matrices in. Just push clear. Okay. So now we can go back to my matrix menu and select what I've put. So second matrix, the names, these are the ones I've already stored. So I want matrix A times matrix B. So they're right next to each other. And then we're going to add them. Matrix A, enter, and matrix C. So it looks just like it does on your paper. What's up? Did you push second mode? Yep, the button right next to it. Okay. And then we can push enter. So yes, it is the same as what we just did. So matrix distribution is a thing. It does work. Okay. So it was the same. So matrix, I'm going to be mathy here. So A times B plus C was the same as A times B plus A times C. So matrix distribution works. Okay, they are the same. We good? Yes? Now we know how to use calculators, which again, great tool, great resource, but you have to make sure you type in the right stuff. Otherwise, it's all going to be wrong. Okay? There's also still work to show me, which I'm going to show you in the next problem. Okay? You can't just type things and throw answers at me. I need to see what did you set up. Okay? What did you type in? And then you can tell me what the answer was that you got. Okay? So for this real life problem, we can use matrix multiplication in business applications because an inventory matrix, when multiplied by a cost per item matrix, it's going to result in a total cost matrix. Okay? The column labels for our inventory must match the row labels for the cost in order for our total cost matrix to make sense. Okay? So our labels also have to match. Not just how many I have, but what they represent have to be the same. Okay? Here we go. 2 groups buys tickets to the Orlando Science Center's Pompeii exhibit. Each youth ticket cost $18. Each student ticket cost $23, and each adult ticket cost $26. Use matrix multiplication to find the total cost of the meals for each class. Okay, so they gave me a setup already for the inventory. Okay, the groups and how many tickets they have. So let's go ahead and set that up as a matrix. So we have group A and group B. We have 5, 6, 3, 4, 6, and 8. This represented youth tickets, student tickets, and adult tickets. Okay, so this is my inventory. We're going to multiply that with a cost matrix. So those labels, remember, they have to match. So in my cost matrix, my youth, student, and adult are now my row labels, and my column will be their cost. Okay, so what's the cost of a youth ticket? Cost of a student ticket and cost of an adult ticket. 26. So I would need to see at least this before you start typing it in. I would need to see the setup. Okay, so you choose to either do it by hand or do it by calculator. I'll let you pick your own route, work this one, and let's see what we get. Do we have a total cost for group A? What you got, Thomas? $315. Yep. So the total cost for group A is $315. And I heard someone say it, what the total cost for group B? $408. Good. So if you did it by hand, my work is up here. If you did it by calculator, then that top matrix you probably don't have, right? That first green, red, okay? And that's okay. If you did it by calculator, you're not going to have that. Everything else, though, you're going to have, okay? So you still got to show me what you did. Notice my dimensions, right? It was group by ticket times ticket by cost. So just like what it said that was going to happen earlier, is that your outsides become the dimensions of your answer, right? We got group by cost. Okay, so the labels also match up with the multiplying dimensions rule. Okay, if your labels match, then your outside labels will be the dimensions of your product. Yes, sir?
So matrices just use the mass multiplication.
True. Yeah. Yep. Yes, sir. Yes.